Hello guys, welcome back to another AMC problem solution. Today I have yet another question here, and this is actually from the 2021 part A, and this is actually the 25th question. So first, let's start off by reading the question as always. So, how many ways are there to place 3 indistinguishable red chips, 3 indistinguishable blue chips, and 3 indistinguishable green chips in the squares of a 3x3 grid so that no 2 chips of the same color are directly adjacent to each other, either vertically or horizontally? Now, I've already drawn a couple of squares here, so I'll be just using these. Now, without loss of generality, I will label some of these squares as 1, 2, and 3. So, let's first start off by analyzing the top 2x2 corners. So, we have 2 ways to do this. Have 1, 2, 3. Oh, sorry, I did that wrong. 1, 2 here, 1 here, 3 here, or we can have 1, 2, 2. Right, so this is how we do it, and this number, this blank square, this is subjective to change. Now, these 1, 2, and 3, obviously they are not G and B, like the red, blue, and green, and we will be changing these later on. So we will assign like 1 equals to red, 2 equals to green, and so on. So first, let's start off with this. And first, let's start off with 1, which is the number we use the most of. Now, we can see that 1 has only 3 placements here. We place 1 here, 1 here, and 1 here. So we can place 1 here, and when we place 1 here, we have 1 solution. So we get to put 2 here, 3 here. I'm sorry, we're going to put 2 here, 2 here, 3 here, 3 here, and that is the only way to solve this. If we place 1 here, it would be the same, and here, it would also be the same. So for this case, we have 3 different cases, and then we have to multiply by 6, as we need to assign red, green, and blue to 1, 2, and 3, which would be 3, which would be 3 factorial, or 3 times 2, or 6. So we have 3 times 6 options here. Alright, now let's go look over here. We have 1, 2, and 2. Now let's look at where we're going to put the 1s. Now in this case, we have to place down 2 1s, and there are 2 ways to place this. We can place 1 here, 1 here. Actually, there's 4 ways to place this. We can put 1 here, and 1 here, 1 here, and 1 here, 1 here, and 1 here, and 1 here, and 1 here. Now, I will start off by over here. I will look at 1 in particular, which is, what if we place 1 here and 1 here? Now we can try and solve this by placing 3, but you'll realize, hold on, we still have 3 chips that we haven't placed, but there's absolutely no way we can place all 3 of them in this 2x2 grid so that none of them are adjacent to each other. So in other words, if you place 1 here and 1 here, this would not work out. But if you place 1 here and 1 here, and we remove this one, so instead we have an empty square here, you'll see that we still have 3 chips left. We still have 3 chips that signify 3, and there is a way to place them. So you can have 1 here, 1 here, and 1 here, right? So 3, 3, 3, and then by symmetry, we also have one where we have 1 here and 1 here, and then also the last case, which is if we have 1 here, kind of similar, we can also place the 3 3s correctly. So 3, 3, 3, 2. So in other words, here there are 4 ways to place the 2 1s, but only 3 actually work. So we have another 3 times 6. So in other words, our answer should be 3 times 6 plus 3 times 6, or 18 plus 18, or 36. So the answer to this question should be E. Thank you guys for listening. If you have any other ways to solve the solution, as always, please tell me in the comments, and thank you for listening. Bye.